This is a free body diagram of the safe, with the forces of the horses and the friction acting upon the safe. The force of the horses has to be greater than the force of friction in order to accelerate the safe like it did in the movie. Given that mu is force of friction over the normal force, and the normal force is mass times the acceleration due to gravity, and the force of friction is mu times the normal force, we can find the force of friction if we know mu and mass. So now we're going to find the mass of the safe.
To do that, what we're going to have to do is find the volume. So what we did to do this was create a big cube and a little cube, because the safe is hollow. And we used Johnny Depp's height to estimate this, and we got 6 by 6 by 8 feet, which gives us a volume of 288 feet cubed. So now what we have to do is find the volume of the little cube, that's the hollow part of the safe. So we used this scene to estimate that it was 6 inches thick, the walls, which gives us the dimensions 5 by 5 by 7 feet, which creates 175 feet cubed. Which means that the volume of the safe is 288 minus 175, which is 113 feet cubed.
Okay, so given that volume that we found, to find the mass of the safe, we searched up the density of steel, which was 223.7 kilograms per cubic feet, and we got 25,287.1 kilograms as the mass, which we plugged into the normal force equation, and we got 247,725 newtons.
To find the force of friction, we multiplied mu times the normal force that we just found to get 141,203.467 newtons. The horses must have a force greater than that in order to accelerate the safe.
So now let's work on the force of the horses to see if they overcome the normal force. So we researched and found out that one horse can carry 650 kilograms comfortably, which means 12 horses can carry 7,800 kilograms comfortably.
So we also researched that the maximum acceleration of a horse is 7.5 meters per second squared. And using our calculations in the last clip, we determined that the maximum force that a horse can comfortably generate is 58,500 newtons. And keep in mind, this is at their maximum acceleration, which they were not going in the clip.
So in this video, we found that the force the horses can generate is 58,500 newtons, whereas the force of friction on the safe is 141,203 newtons, which means that the horses cannot accelerate the safe.